Now, first off, when they did this example on 1, they made a mistake, and I hope you all caught it. It says create this table such that each y coordinate is 4 more than the corresponding x coordinate. So the coordinates they picked for x were 2, 5, and 8. Now it says each y coordinate is 4 more. So the rule for y is x plus 4. Whatever x is, we're going to add 4. So 2 plus 4 should have gave them 6 here, making this 2, 6. And on the next one, 4 plus 5 should have gave them 9 here. So it would have been 5, 9. And 8 plus 4 should have gave them 12. So it would have been 8, 12. So let's go ahead and plot these coordinates now. Well, 2, 6 would have brought us right here. Okay. And 5, 8. Actually that's 5, 9. Would have brought us right to here. And 8, 12 brought us right to here. So now we're going to draw our line. Yeah, I'm trying to use a straight edge, but it's making it hard with using this tablet. Our straight edge should look approximately like this. Now, as you can see, the line was actually just parallel with the one they drawn. They were 1 off. You can see how easy it is to get 1 off. Now, it says give 2 coordinates that fall in line with x coordinate greater than 18. Now, we find our y coordinate by adding 4 to x. So greater than 18, I could pick any number. I'm pick 19, that's greater than 18, and 20. Now when I use my rule of x plus 4, and the 19 plus 4 will be 23, and 20 plus 4 will be 24. And I know both of those points will be on that line when I extend it out, just because on the next one it's telling us to create such table y coordinate is 2 times as much as corresponding x coordinate. Now, since I get to choose this time, I love using 0 as x, as a base, okay? And then I'm just going to go 2 and 4. Now, it says 2 times as much, so I know this is going to be x times 2 to find y. Well, 0 times 2 is going to give me 0. 2 times 2 will give me 4. 4 times 2 will give me 8. So I know my coordinates are 0, 0, 2, 4, and 4, 8. Now I'm starting here at 0, 0, and I'm going to 2, 4, and 4, 8. And I'm going to connect these best I can freehand. Now, you may not have picked the same coordinates, but they should have been on that same basic line, okay? Because anything with the x times 2 would have started off at 0, 0 and would have extended all the way up. Now, if I'd have picked 6, my other coordinate would have been 12 up here. So the line would have continued to extend all the way up to here. And your points would have been anywhere on that line. Now for C, give the coordinates of 2 other points that fall on this line with y coordinates greater than 25. So basically, I need to multiply 2, because 2 times something to get an answer greater than 25. So I'm going to pick 26. And I know 13 times 2 would give me 36. So I know this would be a point that would be on that. And I'm going to stick with even numbers because it makes it easier. And I'm going to take 28 because that's greater than 25. And I know 14 times 2 is 28. So there's my 2 points. That would still be on that line. Now your sheet's going to look a little different. I made this like this so that it would fit on one PowerPoint slide. Now on this one we're going to be creating 3 different lines. Now the first one says graph these lines on the plane. Well, it says y is equal to y. X is equal to y. So I'm just going to pick some numbers. 2, 2, 4, 2, excuse me, 4, 4 because X got to equal y, and 6, 6. So that gives me order pairs of 2, 2, 4, 4, and 6, 6. So now I'm coming up here to 2, 2, 4, 4, 6, 6. I'm going to do my best to connect these straight as possible. Okay? Now this here is line L. So I'm going to go ahead and it's designated as line L. Now the next one, it says line M is 1 less than X. Okay. So you know what? I'm going to go ahead and pick the same numbers. 2, 4, 6. And I know this is 1 less, so it's X minus 1. Where this one over here was actually X equals Y. Now 2 minus 1 gives me 1. 4 minus 1 gives me 3. 6 minus 1 gives me 5. So I end up with 2, 1, 4, 3, and 6, 5. So let's go ahead and plot those. So we have 2, 1, 4, 3, and 6, 5. And let's go ahead and connect these. And this is line M. Now, the last one, this is line N, is y is 1 less than twice X. So you know what? I'm going to keep the same just to show you what it looks like. 2, 4, and 6. And this y is 1 less than twice 6. So that means that's 2 times X plus 1. And I really should have made that a smaller X for you. So 2X plus 1. So I can say 2 times 2 would be 4. Actually, that's minus 1. Let me rewrite that. I'll write it down here. The rule is going to be 2 times X minus 1. And we know anytime we have a number and a letter next to each other, that's a multiplication. So now I got 2 times 2 is 4, minus 1 gives me 3. 4 times 2 is 8, minus 1 gives me 7. 6 times 2 is 12, minus 1 is 11. So I end up with 2, 3, 4, 7, and 6, 11. So I'm coming up now to 2, 3, 4, 7, and 6, 11. Now, hopefully I'll be able to connect these without being too off. And this one here is line N. Now it says, which lines intersect? Do any of the lines intersect? If yes, which ones? And give the coordinate of their intersection. Well, if I extended this out, let's try this. One thing I like doing, like most of them, on this one here, if I'd have chose 0, that would have been 0. So L would have extended all the way out right to the 0. Now on M, if I chose 0, okay, for my X coordinate, it would have been 0 minus 1 would have actually continued to follow down here, And we don't know this yet, but it would have went to a -1 down here. Okay. Now, for our y coordinate, excuse me, for our line N, if I would have took 0 here, been 1 more than twice x, so 2 times 0 would have been 0 plus 1. Actually, it would have been -1 again. Okay. So it would have continued down to -1. And you could have seen line M would have intersected both of them. Okay. So it would have actually intersected both line M and N. Are any of these parallel? Well, you can see that line L and M are parallel. Oh, why don't you give the coordinates of their intersection? Okay, let's see. Well, since we're not talking about negative coordinates down here, the only one we'd have seen that would have intersected would have been N, N, L, and that would have been at coordinate 1, 1. All right. The last one down here, give the rule for another line that would be parallel to the lines you posted in problem 3C. Okay, talking about the parallel lines. Now, as you can see, this one here in line M, y is 1 less than x. Okay, so L being equal, if y is 1 less, it would have been, it's parallel. So I could have said, for this one here, y is 2 less than x. Or I could have said y is 3 less than x. And that would have all kept on making them parallel and go down. Now, what about if I said y was 1 more? Would that have been parallel? Well, let's see. Let's take these same numbers, and we did 2, 4, and 6, and I'm going to do it over here just to show you. So 2, and I'm going to say that the rule is x plus 1 instead of x minus 1 that we did for line M. So for 2, that means y would have been 3 for the order pair 2, 3. If I picked 4 like I did the others, then that would have been 5. So that'd been 4, 5. And the last one was 6, and then plus 1 would have been 7. So it would have been 6, 7. So let's see what that looked like. Now, first it said 2, 3, 4, 5, and 6, 7. Oh, 4, 5. That one's wrong. It's supposed to be here. 4, 5. Now, if you notice, when I connect these three, they are also still parallel. So, if it's x plus 1 or x minus 1, it's still going to be parallel to x equals y. Just depends on which side of the line that you end up drawing it. And I hope you understood that. All right? All right. Thank you.